Welcome to determination of soda ash. So in this experiment we're going to be using hydrochloric acid to titrate some soda ash and determine the quantity of sodium carbonate that's in the soda ash sample. We were going to have to determine the concentration of the prepared hydrochloric acid by titrating it with sodium hydroxide. But we also have to determine the concentration of sodium hydroxide. Now we want it to be 0.1 molar. We're going to mix it up from a concentrated solution. So we start off with 5 molar sodium hydroxide right over here. And you're going to have to calculate the quantity that you'll have to add to a half-filled bottle of distilled water in order to produce a solution that should be about 0.1 molar. So let's add. I already calculated, measured, and now I'm adding the sodium hydroxide into the bottle. Then I'll top off the bottle with distilled water so that it contains about 500 mils. Notice that none of this is real exact. We're going to determine the actual concentration inside the bottle in a little bit. So there's our sodium hydroxide. We do want to make sure that the solution that we've just prepared is homogeneous. So you'll want to invert the bottle several times. Likewise, we'll take some hydrochloric acid and you have to calculate. First we'll rinse out. I'm going to use the same graduated cylinder, so I should rinse it out. If I'm being very careful, I'd want to also rinse it out with the hydrochloric acid solution before I use a different solution. So okay, why not? Let's be careful. Again, the actual concentrations I'm mixing are not going to be super important that they have to be exact, because we are going to measure with a good deal of precision what they actually are. So I calculated how much hydrochloric acid of the 5 molar that I'm going to need in order to produce 500 milliliter container of 0.2 molar hydrochloric acid. So here is my measured hydrochloric acid. I will pour it into the bottle. And then notice I'd already half filled the bottle with water. You want to always do that. You don't want to add water directly to a concentrated reagent, because sometimes a lot of heat will be let off by the abrupt ionization of the dissolved components. Depends on what it is, and it can be quite dangerous. Okay, so there's my hydrochloric acid bottle, and here's my sodium hydroxide bottle. So right now the labels say 0.1 and 0.2, but how close are we to actually being 0.1 and 0.2? That's what the next processes in the lab are going to be used to determine. Next, we're going to prepare to standardize our sodium hydroxide to find out how close to 0.1 molar it really is. We're going to use the solid acid KHP to do so. I have my Erlenmeyer flasks 1, 2, and 3. I'm going to measure out about 0.7 gram samples to do this. So I'm going to use this weighing paper, and first of all I will zero out the weighing paper, and then I'm going to add the KHP. So it gets to be about 0.7 grams. So you can see there what your mass of your KHP is. Now let's put that into our number 1 Erlenmeyer. As careful as we can without losing any of the KHP. Okay, so for being super careful, we would rinse the paper with some distilled water to make sure it all got in there. But we're going to be okay, I think. Looks like I did pretty well. I don't see any left on the balance. A little bit had spilled from the earlier, but I don't think that mass was measured, so it should be good. Now, re-zero the scale. a fresh piece of paper on. Re-zero that value. And then let's get another 0.7. Now that I see about what that mass is, for your data, that's going into flask 2. And then finally, flask 3. And then let's get that into our third flask. And here we go. That's the measuring of the KHP. Now, in the interest of time, I've rinsed and filled this burette with our 0.1 molar sodium hydroxide prepared solution using proper technique. I ended up rinsing it through 3 times, and then making sure there were no bubbles in the tip, and making sure that the level at the top is below the 0.0. Now I'm going to put you up there. Actually, let me just lower it so it's a little bit easier for me to make sure I get a good shot, and make sure that you can read that you're at. Now, let me see if the numbers, oh, there we go. And sometimes if you put a little darker background there, it's a little bit easier to read. Oh, that's our initial volume for our first titration of the KHP. Now, to prepare the KHP, I have this Erlenmeyer flask here that has the dry KHP. This is number 1, and we're supposed to add a certain volume of water to it. Again, it doesn't matter how much you add as long as it is fully dissolved. And so I'm going to dissolve that up. Something I also don't have is a little squeeze bottle, so I'm going to go grab that as well. You think you have everything, and notice it's still not dissolved, so I want to make sure everything's down here, and vigorously make sure that all of the KHP is completely dissolved. You want every mole dissolved in the solution. Okay, so then we have to add our indicator. Our indicator is phenolphthalein, so here it is, and 3 to 5 drops. Again, the exact amount's not super important. So I did about 5, which, I don't know, whatever. And there we go. Now, the phenolphthalein is going to turn pink when an excess of base is added. So I'm going to titrate until I get a faint pink endpoint. Now I'm going to use some white paper so we can visualize that. And I'm going to do this as efficiently as I can, but on the other hand, we want to get a good result. So if you watch the preparatory video, then you should be able to calculate about the volume this titration is going to be required, assuming that the concentration of the sodium hydroxide is what we said on the bottle, around 0.1. So let's see, I did that calculation earlier, so I'm going to go ahead and open up the throttle and let it go. And we're not going to be scared. We're going to be confident that we mix this up correctly, that we weighed everything correctly. We should be about 0.1 molar, and we're not going to go over as long as we stop before our calculated number. And you can see that it's turning a little bit pink, and I'm not letting that worry me. If I swirl a little bit, you see that the pink goes away. You see the pink? And it goes away when I swirl a little bit. Probably should watch the value. It's down at 17 now. And it's going down, down, down. Do you have that number in your head? Did you calculate it? So you're going along. I will stop it fairly soon. Turning red, but I'm not worrying. I am unafraid. And pretty soon I'm going to stop it. And we're going to stop right here. Yeah, swirl, swirl. Look, it went away, no problem. I'm not to the excess yet. So because I added rapidly, that means a lot of splashing probably occurred. So I'm going to rinse down the sides and make sure that any splashed moles are up in there. Now, from here I'm going to be careful. So being careful as you get more and more experience with pipetting, initially I'm just going to add squirts and swirl. And as long as it's not lingering very long, I can feel pretty confident that adding a significant squirt is not going to put me over. And when it starts lingering a little bit longer, then I'm going to start slowing down. Okay, so I might back it off a little bit here. This takes patience, which I don't have, but hopefully I'll have today, because your result's going to be my result. You want it to be good, right? Yeah, it's looking a little bit. So we're just shorten the squirts, so you're not adding quite as much with each squirt. And then every so often, so with a larger squirt like that, we'll want to rinse down the sides and make sure everything is looking good there. Okay, it's still going away pretty easily. Ooh, that's lingering a little bit more. Ooh, that lingered a little bit. So now maybe I'm going to start adding just 1 or 2 drops at a time, since it's lingering a bit more. Sometimes if the drop is just hanging off the tip and not falling in, I'll even squirt it off with the wash bottle. Sometimes that's enough to get it to change. See how squirting that little hanging drop with the wash bottle made it blush a little bit? So I think I might be getting close. There's 2 drops. Oof, okay, I think I'm close. So I really want to try and just hang 1 drop at a time. Got it perfect. That's nice. See that? I haven't done one of these for a while, so I'm feeling pretty good about myself right now. There's a nice pale pink that just took 1 drop. That's it. Now, it's important that if you think you didn't hit it, like if it's pale, this is pretty good. It's not too pale. This is absolutely the end point. I am not concerned that I undershot it at all. But if I thought I did, what I should do is take a reading. Let's go ahead and do that. So I'm going to line you guys up, hang on, with the burette so you can read it. Okay, I think that's pretty good. I see the number in the shot. Should be able to read that meniscus nice and level. Eye length. Okay, so that's our end point. So if you think maybe, okay, I don't think I got it. I think it faded and it was kind of an undershot and maybe I just didn't swirl enough. Then adding, make sure you read it, and then add 1 more drop. Actually went a little bit further than I thought, but that's okay. We'll add 1 more drop and watch what happens. Boom! Super red. That's actually not too bad for a student, but I would consider that to be a disaster if I was like in an analytical chem lab. Now what I'm going to do the other 2 titrations because we do need to do this in triplicate. But you don't need to watch them again. You've seen a good one. So those, I will give you shots. I will take photos of the initial and final burette readings for you. hydrochloric acid is so we can do our chemical analysis for sodium carbonate in the soda ash. So what we'll want to do is titrate then the hydrochloric acid with the secondary standard that we have now, the sodium hydroxide. Now the sodium hydroxide concentration is known. So I'll put some of the hydrochloric acid out of my main stock bottle into a clean beaker. And I've already rinsed out the pipette with the hydrochloric acid, so I'm not going to do that for you again. I'm just going to go ahead and directly pipette the hydrochloric acid from the beaker into this Erlenmeyer flask. So let's take a look at that. Remember with pipetting, we're going to squeeze the bulb. We're going to use the bulb to draw the liquid up into the pipette. Again, you should always pre-rinse your pipette, but I've already done that. And we'll catch it there and get the meniscus right on the mark. Right there. Don't know if you can see that. Why not? Anyway, into the Erlenmeyer flask it goes. It was there. And we'll let it drain to the Erlenmeyer flask. Now, one thing that's not in the procedure that I should have put in is that with this 10 milliliter pipette that we're using here, that's not a whole lot of volume. So when we put it into the Erlenmeyer flask, it's pretty shallow. So in order to see a nice, even pink color for our end point, it's nice to have a little bit more volume water in there. So I'm going to go ahead and add some distilled water. Again, that's not going to affect the amount of moles that I'm going to have in the Erlenmeyer flask. The moles will be the same, and it came from 10 milliliters out of this stock bottle. That's the pieces of information that I need to know. But adding a little water is going to help me visualize the end point better when I get there. So here's my phenolphthalein. Put in 3 drops. If I add a little more, it's okay. If I add just 3, it gives me a little bit paler color, a little bit easier sometimes to get a nice clear end point. Now let me show you the starting volume that we're at on the burette. Get us up there. You can see with that background of the whiteboard, it makes it kind of easy to read, and I'll move it around so you can get those numbers and read the volume. That's your initial volume for the titration of the hydrochloric acid with the sodium hydroxide. Now let's take a look at the flask so you can see the end point. We saw this one earlier, it's still the phenolphthalein end point. So not real new here, but we'll still have you watch one, and then I'll do 2 off camera that I will give you just the burette readings for that you can look at. Okay, whew. That was an adventure. So here we go. Because it's 0.1 molar, I know it's a little less than 0.1 molar, if you calculated it correctly, actually, and it's 0.2 molar hydrochloric acid, 0.1 molar sodium hydroxide, I should know approximately how much volume this should take. So again, in order to speed it up, I'm just going to go ahead and open up the valve and let it rip until it's pretty close to what I think the tentative endpoint's going to be. Maybe I'll go within a mil of it. Without worrying too much about going over. And it might get a little red here, but I'm confident that when I swirl it around, that red will go away, because we will not really be at the end point yet, unless I've mixed up a solution wrong or made an error somewhere, which I hopefully have not done. If I did, I wouldn't be showing you the video. I don't think we would tape it again. Oh, seems a little slow for some reason. Have it open all the way. Patience is important. It was always my downfall in the lab as a student, just patience. Okay, you see it getting pretty red. I'm not worried. I'll show you when we get close. It's like a little scary, isn't it? Like, oh no, she's going over. She's going over. She's definitely putting in too much. No. Okay, we'll stop it there. And nope, not too much. So we know it lingered pretty good, so we know we might be pretty close. So I'm going to be a little bit careful and just be tentative and see how quickly it disperses. It's hanging around a little bit, so I'm not going to add the big generous squirts maybe that I did in the earlier titration, and just go a little bit more tentative. Little smaller squirts. Probably going to start transitioning into drop. Yeah, that's hanging around a little bit. So I'm going to transition into just doing this drop-wise. Instead of squirts, we're adding drops. So to add drops, I'll just rock it forward a little bit and then back. 1 or 2 drops at a time. And you know, I think I'll take this opportunity then to make sure that all my reactants are where they're supposed to be, and just rinse everything down the sides. Everything needs to be at the bottom of the Erlenmeyer. Of course, there's always some water droplets clinging, but all the reactants should be forced to the bottom. Whoops, I meant to do a drop and I just squirt. But luckily no harm was done, as the red did not linger. So let's do another drop. And another drop. Sometimes if I think I'm really close, I'll just hang part of a drop on the tip and then wash it in like that. And that's how I can get a really tight end point if I do it that way. Oops, it's going to be too dropper on this one. If you do see a drop hanging on the end of your tip, you should wash it off, by the way, to make sure that anything that's, you know, that's actually officially out of the burette's volume is being measured. I think it's getting there, guys. The hanging drop. Boom. Okay, it's close. Close, close. I don't know, feeling anxious? You would be if you were actually doing this live. I'm not anxious. Boom. And that's it. That's pretty good right there. So it fills it. It's fading. It's fading pretty fast. Hopefully you could see it. But I'm confident that that's the end point. Oh, it's faded. That faded really fast. So tell you what, I'm gonna add one more drop, but let's take a reading first, just in case. So I'm gonna push you guys back up here, because I don't know if it lingered for the required amount of time. It should be there for 30 seconds anyway, and it seemed like it faded pretty darn fast. So let me get out of the way and get the whiteboard back there and turn this so you can see the numbers. Okay. And I'm going to add one more drop. And if it's still pretty light, if it's faint, then we'll take one more reading. And it probably won't change by much unless I accidentally add in a whole blob full at once. But I'm going to try and be super careful. I'm going to hang a drop and then wash it in. So let's see how this goes. So right now I got nothing. Come on. Okay, so that's a hanging drop. There it goes. Back it up. Oh yeah, so we were there, right? That's pretty dark. Wow. So that reading that I showed you stands. You won't have to adjust that at all. So from that you should be able to calculate, well, I'd be able to calculate the concentration of the hydrochloric acid from there. So before we begin the titration, we'll add 10 drops of our indicator. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, it's not super important that be exact, nor is it super important that the 40 milliliters of water that we added be exact. Now we see it's green, and when people do this in the lab, my advice that I typically give to them is to keep titrating until you don't see a green tinge anymore. Now it's not going to be the nice sharp endpoint that we saw with the phenolphthalein. So the other trick to this is the fact that we don't know where the endpoint's going to be. I don't know how much sodium carbonate is in the sample. So therefore that means that from the beginning of the titration, I'm going to have to be a little bit cautious and careful. Now, that's too bad. Oops. I'll have to go back and look at the tape and see. Anyway, that should be good. Should be able to read that right. Got it? Alright, super. So we're going to go ahead and add the fast amount this time. I'm going to take all that time like I did last time because I know about where the endpoint is now. I just want to hold back. Went just a nice squirt too far. So I know that I can add close to that and be probably alright. So we'll let her go. Watching the burette to make sure I'm not going to go too far. Okay, I'm going to stop it right here. Ooh, and you can see do you see that blue color in there? Now it went away when I swirled, so look, that's looking pretty good, like a nice place to stop. So rinsing down the sides. See some of it's kind of crept up there a bit. Get it down there, everything down there. Okay, so now I'm going to be careful. And hopefully I'll be able to manage this burette a little better than I did the last time. Wow, already I'm squirting. Okay. Should get that other burette back, but I couldn't get any liquid out of the tip. I'll just grab another one. This one, like I said, is a lot harder to handle. There, I got a hanging dry now. Maybe now that I'm a little more used to it, I won't have the issues I was having. Alright, let's get some more in there. Talk. Okay, so here I am going dropwise. This time I'm going to be really watching it so that I don't accidentally put in a squirt rather than turning it off. So I'm turning it towards me to get it to drop. That means I have to turn it away from me to get it to stop. Come on. I feel like it's close. I can see the purple kind of appearing when the drops go in now. Yeah, oh, that's close, 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 close. So you see this changed a little bit of the shade here. Now I want it to be blue-gray. It's still got a little green tinge to it, so I'm going to try and just add a drop and edge that green out of there. So again, I gotta be super careful. This thing's touchy. Close. Very close. I still feel like it's a little too green. Just a bit green. So I'm gonna try and get one more drop. Actually, there's a little on the tip, so if I rinse that down maybe. we'll do it. Low, so it's close. I got 2 drops, I don't want 2. But I think I got it, and that's not too bad. I might have added one drop more than I needed. That's what we're looking for. Nice blue-gray. Not looking green anymore. Just blue. So let's see what the volume was this time. Too bad compared to last time. Again, that first time's probably, it's an overshoot. We're gonna have to go with it because I'm not weighing out another sample and don't have enough in the unknown. And that's just the way it is. Where's the meniscus? I can see it pretty well, but it's not showing up. Oh, I'm not high enough. There we go. So there's your meniscus. Let me turn it so you can see the numbers. And against the whiteboard, I think it's pretty, you can read it pretty good. Turn it just a tad more. There. Okay. So I will do the third one then off camera and just take pictures of the initial and final volumes for you. And that's it. You should be able to do your calculations from there on following the lab instructions.